Okay, hello, thank you for joining this webinar session today. I am Choi, and geotechnical engineer in MIDAS IT. I'm happy to announce about our series of case study webinar continuously. Today also, I'm carrying out the case study session based on the real project done by MIDAS users. Firstly, I would like to introduce about today's project case, which is earth retaining stabilizing system for detention tank. And this project has been done by Singapore Metro Consulting Company from Singapore. Okay, and this is the drawing of the excavation layout plan to verify the location which we are performing the analysis. And I'm going to carry out the 3D analysis for this excavation project. And I would like to tell you why. For this kind of excavation analysis, generally you are dividing the section to perform the 2D analysis. However, from the 2D analysis result, we are not able to consider the corner effect on the retaining wall, support system, and movement of ground. Probably this is called conservative design. The main reason why we perform the 3D checking is to verify the effect, such as load transfer. Then you can get a more accurate result and can do the economical design for your contractors. And I will use the 9 number of boreholes to assume the ground condition with a bedding plane function, which is supported by GTS NX Program. I will take those boreholes from SI report, which is provided by our users. And there are 4 layers of soil. And first layer is assumed by fill, second is marine clay, third is S6, and rest is S5. Give me a moment. Can you see my presentation? Sorry about this. Okay, this is the drawing of the excavation layout plan. And this is what I said about the 3D analysis. Why do we need to carry out the 3D analysis? And this is the bedding plane function, which is provided by GTS NX Program. And I will use a 9 number of boreholes, as you can see there. And there are soil properties, as you can see on the screen. Soil type is assumed by hardening soil in this case study. And you can see elastic modulus, cohesion, and friction angle for each soil from this table. In this slide, you can see the drawing for the section view. As you can see in left-hand side, there are 2 layers of strut and retaining wall for these excavation works. And right-hand side, you can see the generated model for that retaining system. And retaining wall will be assumed by sheet file FSP4, and strut and waler will be assumed as you can see under description of structural detail under here. And you can see the structural properties in the table. And I assume the structural properties as an elastic material and give a reasonable values for elastic modulus and Poisson's ratio and others. And I will use shell element for retaining wall, the sheet pile wall, and we'll use the beam element for waler and the truss element for strut. And I will assume the analysis stays as follow this drawing of construction sequence. First, I will excavate down with the slope and activate the retaining wall, and excavate down and install the support system such as a strut and waler until the final excavation level. And basically the process of the analysis is same as general FEM analysis, and geometry, mesh, and define the analysis stage and check the result such as movement of ground and displacement and forces from structure. And let me open the GTS NX program and carry out the analysis process. Okay, I think you guys can see the GTS NX program. Can you guys see the GTS NX program? What I open? Right. Okay, so when you open the GTS NX program, then you can see this window, and there are some tabs to proceed the analysis, and there is some functions under here. And this is the control for view. Okay, so under the mesh tab from material function, then there are materials what I made. For the fill, I assume the hardening soil as I said. And here is the general properties for the hardening soil model. Poisson's ratio and unit weight, and porous for the permeability. And under the nonlinear tab, you can assume the elastic modulus here for the hardening soil and others, and cohesion and friction angle here. And if you want to assume the small strain parameter, you just check here. And this is the strut and waler for the structure. And I assumed it with the elastic model type and give some elastic modulus and Poisson's ratio unit weight And for the sheet file, I assume the sheet file with a 2D orthotropic here. Then you can assume the elastic modulus for this sheet file and Poisson's ratio and shear modulus. And under the properties, you can control the structural part using the truss or beam or shell under the property. And the soil properties I assumed as a solid, as you can see here. So firstly, you need to give the material property under the material tab here. And you need to assign the property under here. Okay, so first I will import the CAD file. Before that, I will change the work plane under here. Then when you double click this one, then you can see the work plane has changed at the XY plane. Just do the double click. Okay. Work plane means you can draw the line or other geometry under this plane. Okay. And I will import the CAD file, the DWG format. Okay. And under here, I said I will use a bedding plane function. This one. So there is some location for the reference boreholes. So as I said, there are 9 numbers of reference boreholes. So click this one, the bedding plane, and give the name BH1 or 2. And this is the location. Just click here and just click the location of the boreholes. And you can change the plane name under here. Field, marine plane, or something like this. And you can give some depth under this tab and 10 or 20, something like this. And if you want to add one more boreholes, then just change the name and delete the location and select the location and change the depth. That's it. But in this case study, I will use import function, which is format with a spreadsheet here. And you can find the sample for this bedding plane under the installation folder and find the sample. Double click here. Then you can see the bedding plane sample. Okay, so you just type here and just import there. And I will show you what I made. Okay, so here is the borehole's name, and here is a location, XYZ coordinate system, and this is the name. If you have more plane, then you can add
more under here, 4 and something. And this is the depth under the which borehole, like this. Okay. And just import this one. Then you can see the boreholes. What I indicated inside the spreadsheet. And I will give the distance 20 and 20. And geometry set name, soil layer. And okay. Then you can see the created soil layers with the face like this. And I will use these faces for the cutting the ground solid to assume the soil layer. And I will hide this soil layer first to proceed others. And go to top view. And you can control the viewpoint. Just click here, top, bottom, left, right. Okay. And I will delete meaningless part, the borders. Okay. And there are slope excavation part from here to here. So I will move this part to different level, 2 meters below down. Okay. And I will hide the grid. And as you can see here, it is moved to -2 meters like this. Okay, and first I will create the solid for the ground. So using the extrude function here, and change the selection method to edge here, and select the edge for the ground, and select the jet direction, and reserve direction, and I will give the 60 meters. And you can see the preview using the preview mode under here. And if it is correct, then just click OK. And this is the ground solid. And also you can hide and show under here. Okay, so next I will create for the slope part. Firstly, we need to create a face. This is the bottom part of the slope. And this is the top part for the slope. Okay. So from the GTS NX, there is some special function called the loft. You just click this one and click the two faces and just click OK. Then, as you can see here, there is a slope, which is using the two faces from the top to bottom. Okay. And I will hide this as well. And the next, I will create a solid for the excavation and retaining wall part using the extrude function again. Change the selection method to edge. And select the directions. and check reserve direction and 18. The length of the retaining wall is 18, so I'm using the 18 for the length. Okay. So there are 3 solids. One is for the ground, and one is for the slope excavation part. Another one is main excavation part and retaining wall. Okay. Okay, so the next I will create the strut part and waler part. So before that, I will intersect for this part. Okay. And first for the strut, I will copy these strut lines to strut levers, jet lever, and I will use a copy. It's 0.5 meter below S1 and apply. And second layer is 3.5 below and S2. Okay. So as you can see here, there are 2 layers of strut. And I will hide those struts and I will delete those meaningless parts. Delete. And for the waler, also copy and paste to exact location 0.5 W1 and 3.5 meter below and W2. Okay. So here is copy. Okay, and I'll hide this one again and delete the meaningless part again. And I will hide everything and just show S1 and S2 and W1 and W2. Okay, and I will use the imprint function for the waler part. It is important part. When I do the mesh, we need to consider the waler part, so I will use imprint function and go to curve and select the solid and select the tool, the waler. Okay. Okay, so the waler lines are considered in the solid here. And the next, I will create the surface for the excavation lever. I will use this face, the bottom of the slope, and using the translate function to copy this face to excavation lever. It's 1.5 excavation layer. And the second excavation is under 4 meter below. And the FER is 5.7. Okay. So we need to divide this solid follow follow this excavation faces. So using this divide function for the solid and select the solid and select the tool surface like this and change. Okay. Then the solid has divided according to the selected surfaces. Okay. So I will type Ctrl G undo. Okay. Before the divide, when you select the solid, it is only one solid there. But after you divide, there are four solids are there. Okay. So the next, I will divide the solids with these bedding plane faces for the soil layer. It is same way, using the divide solid and select every solid and select the surfaces and OK. Then the solid has divided like this. Okay. And I will copy this curve for the water level. It is 1 meter below from the ground surface. So I will copy this edge to 1 meter below and change the geometry set name. WL means that water level. Okay. And I will extrude this line. When you extrude the line, then it will be faces. It's a y direction. Okay. And I will divide the solid again with this water level and divide the function. I select the tool. I will select on the here. Okay. And I will hide this axis. Then, as you can see here, the solid has divided by the faces for the water level. And after that, I will use the auto connect function. Select every solid and OK. So from this auto connect function, then I will show you something. And when you hide this slope excavation part, there is empty. But before that, when you hide this one, it is combined together. So you need to divide using this auto connect function. Okay. So the next, I will generate the mesh for the small part first. So I will hide other part. Okay. So I will generate the mesh for the excavation part first. And just show this excavation part solid and select all, Ctrl A, and right click and generate the mesh. And I will use 2 meter of the size for this excavation part. And I assume the properties for every solid as a sphere at the first time. And later I will change the properties and I will show how. And the next, I will generate a mesh for the slope excavation part using 4 meters of the size. And also assume the properties for the sphere and slope excavation. Okay. And the last part, the ground, I will generate a mesh with the 12 and using the sphere. So this is finished to generate the mesh for the ground part. And under the mesh tree here, you can see the generated mesh under here. And I will show you how to change the parameters for this mesh using the parameters function here. And here is the change the property from the 3D and select object. This one is marine clay, apply. And this one is S6 and S5. Okay. And I will change the inside one also. Hide this mesh set and select this inside one, also marine clay. And you can check the properties under the properties window here. When you select some mesh set, you can see the property and materials under here. Okay. And the next, I will generate the mesh for the retaining wall using the solid, the excavation part on the show here. And I will use the face for the shell element, the outbound here. And using the extract function here, and type change to face. And we need to select the face for the retaining wall, like this. Then you can see the selected part with the green color here. And select the property sheet pie. And I will give the name RW, the retaining wall. Okay. And next, I will use a extract function again to generate the mesh for the waler. So type H and select W1 and change the name. And select first layer of the waler like this and apply. And W2. Select the line for the second layer. Okay. And I will hide this solid. And then you can see the generated mesh for the walers and retaining wall like this. And next, I will generate the mesh for the strut. And I will use this 1D generate mesh function. And division, I will give a 1. This means a node will be created here and here, the start point and end point. That means division 1. If you give a 2, then there are 3 nodes will be created here and mid part and here. But the strut, you don't need to create the node under here. Just create start part and end part. And I will select the properties for S1 and give the name S1 and select object, apply, and show the second strut and select all and division 1 mid 1 and select S2 from the property and S2. Okay, so now I'm finished to generate the mesh for the structural part, retaining wall and strut and waler. And I will show you some function to verify the direction of the structure. So under the property and 1D, then you can see the actual size and actual direction of the structural part like this. And sometimes you are confusing with the direction of the strut and waler to get the bending moment or actual and others. So you can check the direction of the structure with this property tree, show and hide like this. Okay. And the next, I will create the interface element. So just show the retaining wall element like this and click the interface and go to plane tab and from share and select all and merge node at the top part. Like this. And select the widget and give the reduction factor, normally using 0.67 from the Singapore, and create other element, the rigid link, and OK. Okay. So now I'm finished to generate the meshes for the every part. And the next, GTS NX. With the GTS NX, you need to create the boundary conditions like this, using the constraint function under static and slope analysis, and go to auto and click. That's it. And also you need to create the self weight with the GTS NX and self weight like this. So the next, I will create the water level. The initial water level is 1 meter below from the ground. So I will hide this part. And under the seepage and consolidation analysis, you can see the water level here under the boundary. And you can assume the water level with the edge for the 2D analysis, and also assume the water level with the face for the 3D analysis. So I will use a face and just select the face like this and initial, apply. And the next, I will create water level for the slope excavation stage. So face again, just select the face, that's it. And give the name slope excavation. Okay. And for the first excavation as well, and I will hide the first excavation solid and using the water level and face again and select the face EX1. Okay. When you create the water level with a face. This excavation face part will be automatically created by this GTS NX for the water level. Okay, so for the second excavation, also same face, select the face, excavation 2, and final excavation, same face, like this, everywhere. Okay, and the next, I will change the name for the excavation part to easily verify when I create the construction stage. So when you select some mesh set, then you can see it highlighted under this tree. So this is the first excavation, so EX1. The second, EX2. This is a FER. Okay, so if you want to change the mesh set name, just press F2 key from your keyboard and change and enter. That's it. So from now on, so far I finish everything before to create the stage set. So under this analysis tab, you can see the stage set and analysis case. So the first, you need to create the stage set for construction sequence. Right click and add a construction set. And I will use a stress stage type for this case study and add. And when you double click, you can see this window, activate data and deactivate data. If you're activating the data under this stage, like this, and you can see, you can control the show data like this, and slope also. The initial stage, I will assume it as a pure ground condition. And under this first stage, you need to consider the boundary condition and self-weight and rigid link and other ground mesh set and clear the displacement and give a water level and give a 1 meter and select initial, save. So the next is slope excavation. When you press the new here, then you can create next stage. So under here, you need to deactivate this slope excavation. Then you can see they have deactivated and define the water level for the slope excavation like this and save. And next step, install the retaining wall. So activate the retaining wall mesh and interface and deactivate this rigid link and save. And next is first excavation and deactivate this first excavation mesh set and change the water level for first excavation and save. Click new. S1 means install the strut and waler the first level. Okay, save. And the next is second excavation and deactivate this and activate the water level for the second excavation. And second layer of the reinforcement like this. And F here. and deactivate this final excavation level element. That's it. Okay. And you can verify the construction stage using the simulate stage and just play like this. Okay. And when you finish to create the construction stage, then you need to create an analysis case to perform the analysis. So solution type. When you create the construction stage, you need to select construction stage under here and give the title. And under the analysis control, you can select K-NOT condition for initial stage. And under here, you can control the error tolerance. And right click on here, you can solve the program. Then it will be perform the analysis like this. And give me a second. I will prepare to open the result. Okay. So as you can see from the screen, this case contains around 4,000 nodes and 8 stages to perform the analysis. At the left-hand side, you can see my PC's condition, and it is recommended to use NVIDIA's graphic card for reducing the analysis time. So I can finish the analysis within 2 minutes in my computer condition. And based on the feedback from our users, we could have realized that this analysis speed is quite faster compared with other analysis software. So the okay, I will change the screen. Okay, so when you finish to perform the analysis, then you can see the trees under the result tab here. And those stages are what I created under stage set here. So when you double click this one, then you can see the result tree, displacement and some forces and strain and stress. So first see the displacement for the FEL stage. This is the total displacement, as you can see here. And you can control the deformed or undeformed under here. Undeformed and deformed. And you can see the maximum and minimum values directly under this window. Check this values function and unselect, select, like this. And you can control the stage under here. Click here. And you can see the stage name under here. And you can move using your keyboard, the arrow, like this. And if you want to see the forces from the retaining wall, go to Model tab and open the mesh tree and hide everything and just show this retaining wall. Then you can get the result from retaining wall only. And here you can see the shell element forces. Double click here and you can check the membrane forces and bending moment and shear forces from the retaining wall. And under this one, the truss element forces, you can see the actual force of the strut, like this. Because I assume the strut as a truss element. And beam element, you can see the actual forces from the waler. I assume the waler as a beam element. And if you want to see one by one, just hide the mesh set, like this. A second layer. And also you can cut some section from the result using the clip function here. And you can cut some section where you want, like this. And add, close. Then you can see the result from this cutting section. And I will show you how to see the result under the others here, 3D to 2D wizard. And I will unselect this value. And under here, you can directly see the maximum value and minimum value under this cutting plane, like this. And also you can see, just click on the node. The white point is node. So just select and see the result, like this. And you can directly change the unit system under here, right below, and change to millimeter, meter, and millimeter. Okay. Millimeter. And also you can see some the result from the ground surface. And I will change to this. And using this cutting diagram, then you can directly see the result like this. Total. And TZ is a settlement. And also you can directly get the table format from this diagram. Right click and show the table. Then you can see the values with the XYZ coordinate like this. And you can directly copy and paste to the spreadsheet. Just Ctrl C and Ctrl V from this table. And also you can directly copy this window to PowerPoint. And Alt C and Alt V. That's it. Okay.